You are evaluating by multiplying the decimals. We have here several different decimals multiplied together, and I'm going to do a couple of them with you. So 2.4 times 2.4, we can think of that as 24 times 24. 4 times 4 is 16. 4 times 2 is 8, plus 1 more makes 9. 2 times 4 is 8. 2 times 2 is 4. Then we add all that up. That would be 6. 9 plus 8 is 17. 1 plus 4 is 5. But we have to count the decimal places here, and there are 2 decimal spots. So in our answer, we also need 2 decimal spots. For this last one, we can think of it as 1 times 1, which is 1, times 1, which is 1 again. But we need 1, 2, 3 decimal spots. 1, 2, 3 decimal spots. And we put zeros here. This one you can think of as 3 times 3. And then move the decimal 1, 2, 3, 4 spots. Grab a piece of scratch paper or lined paper. We are going to fold it in half as many times as we can and record the number of folds and the number of sections we create. If I fold it 1 time, that gives me 2 sections. If I fold it again, my 2 sections fold over, creating 4 pieces. When I fold my paper a 3rd time, my 4 sections fold over on each other, and I end up with 4 on the bottom and 4 on the top for 8. Then folding it a 4th time, 8 folds over on itself, and 8 and 8 make 16 sections. Then when we fold it a 5th time, that would give us 32 sections or layers. You might be able to get your paper to fold a 6th time, creating 64 sections. Let's add a 3rd row to our table. It will be the number of sections in exponential form. So this is 2 to the 1st power. This would be 2 to the 2nd power because 2 times 2 gives us 4. This would be 2 to the 3rd power. 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. Then 2 to the 4th power, 2 to the 5th power, and 2 to the 6th power. What are the area of the 3 squares? Well, we would do base times height, which is 2 times 2 is 4. 3 times 3 is 9. And 4 times 4 is 16. If we were to write out the multiplication problem, we would do 2 times 2, 3 times 3, and 4 times 4. But if we want it in an exponent form, the base is a 2, and it's multiplied out twice. For this one, the base would be a 3, and it's multiplied twice. And in this one, the base would be a 4, and it shows up twice. How would we write the area in exponential form of a square that had a side length of 17 units? It would be 17 squared. What if that side length was, instead of a whole number, a decimal, like 4.15. Well, then 4.15 would be our base, and we would still square it or use the exponent of 2. And we call that exponent of 2 squared because it's referring to the area of a square. When you square a number, we call those perfect squares. So 1 times 1, 2 times 2, 3 times 3, 4 times 4, you can see that they're making a square. 5 and 5, 6 and 6, or 6 squared, is 36. 7 times 7, or 7 squared, is 49. 8 squared is 64. 9 squared is 81. And 10 squared is 100. So all of those highlighted in pink numbers are considered perfect squares. Here I have three-dimensional objects. These are cubes. If we were trying to find the volume of the cube, we would do the length times the width times the height. Well, in this case, the length is 2, the width is 2, and the height is 2. But we could rewrite that in exponential notation as 2 to the third power. 2 times 2 is 4, times 2 is 8. This one would be 3 long, 3 wide, and 3 high, or 3 cubed. 3 times 3 is 9, 9 times 3 is 27. This is 4 long, 4 wide, and 4 high. 4 to the third power can be said as 4 cubed. 4 times 4 is 16. 16 times 4 is 64. And when we talk about these, we would say units cubed. Just like perimeter is units, area is units squared, volume of cubes is units cubed. If we were asked to determine the volume of this cube, we could write it as 1/2 cubed. The reason we use the parentheses is because we want it to make sure that the whole fraction is being cubed, not just the numerator. So we use the parentheses to indicate that the whole fraction is being multiplied out 3 separate times. If we wrote it like this, that would make it seem like it's 1 multiplied out 3 times, and 2 only shows up the ones. So we don't want this version, we want the parentheses. And then we would do 1 times 1 times 1, which is 1, and 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8. So this cube has a volume of 1/8 of a unit cubed to the third power. For problems 2 through 13, we are evaluating. It might be helpful to write it in expanded form first and then evaluate. This is 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. This is 1, 10 separate times. One times 1 is 1, times 1 is 1, times 1 is 1, times 1 is 1. Keep that up, and you still get 1. Ten times 10 is 100. 10 hundreds is 1,000. And 10,000 is 10,000. This one, the 6 shows up one time, so it is 6. Two times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 3 times 3 is 9. 9 times 3 is 27. And 27 times 3 is 81. We could also think of it as 61 times 61. 1 times 1 is 1. 1 times 6 is 6. 6 times 1 is 6. 6 times 6 is 36. 6 plus 6 is 12. 6 plus 1 is 7. There are 1, 2, 3, 4 decimal spots. So we need 1, 2, 3, 4 decimal spots. I'm going to write them in expanded form. You try and evaluate them on your own, and then you can come back and check your work when you're ready. Pause the video here and evaluate them. Then you can come back and check. Determine whether each number sentence is true or false. Record your choice in the appropriate column. Be prepared to defend your answer. Is 2 cubed equal to 2 times 3? 2 cubed is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So this side is 8. 2 times 3 is 6. 8 is not equal to 6, so that is false. 1 to the 5th is 1 times 1 times 1 times 1 times 1. 1 times 1 is 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 1. 1 is not equal to 5, so that is false. 4 times 5 is 20. 5 plus 5 is 10, plus 5 is 15, plus 5 is 20. 20 does equal 20, so that is true. Is 6 to the 4th the same as 6 times 6 times 6 times 6? Well, yeah, that's written in expanded form. is 1/7 to the third power, 1/7 times 1/7 times 1/7. Yes, that is also expanded form. Is 3 to the fourth the same as 4 to the third? 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. 4 to the third is 4 times 4 times 4. 4 times 4 is 16, and 16 times 4 is 64. Those are not equal, so that is false. 5 to the fourth power. 5 times 5 is 25. 25 times 5 is 125. And 125 times 5 is 625. Is that the same as 5 squared times 5 squared? Here's 5 squared, here's 5 squared, multiplied together. That is still 1, 2, 3, 4 5s multiplied together. So it is also 625, and that is true. Here I have 3/5 squared. 3 times 3 is 9. 5 times 5 is 25. 9 25ths is not the same as 6/10, so that is false. Which expressions are equal to 27? 3 times 3 times 3 would be 3 cubed. That is 9, and 9 times 3 is 27. 3 to the fourth power divided by 3. One of those 3's is going to divide out, and then we have 3 to the third power again. 3 to the third power times 1/3. Yes, one of those, oh, no, one of those 3's is going to divide out. That would be 3 times 3, which is 9, so that one does not work. This one is just 3 to the third written in expanded form. 3 plus 3 is 6. 6 plus 3 is 9, but not 27. 3 times 9 is 27. 3 squared is 9. And then times that by 3, that would give us 27. 3 to the ninth power would be 3 times 3 times 3 times 3 times 3. This is going to be 9, 27, 81. It's going to get way too big. So we should have circled A, B, D, F, and G. Which expressions are equivalent to 4 to the third power? 4 to the third is 4 times 4 times 4. So that's G. 4 times 4 is 16. So 16 times 4 is 64. Oh, I see C has 16 times 4. Four times 3 is 12. 8 squared would be 8 times 8. 8 times 8 is 64, so that one works. 2 to the 6th would be 2 multiplied out 6 times. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And 32 times 2 is 64. This one has 4 times 4 squared, which could be rewritten as 4 times 4. 4 squared is 16, and 16 times 4 is 64. The next one is just a bunch of ones multiplied together. 64 times 1 times 1 always comes out to 1, so this one does not work. Then I have 2 squared times 4 squared. 2 times 2 is 4. 4 times 4 is 16. 16 times 4 is 64. For number 16, we should have B, C, D, E, G, and H. Write 4 different expressions that each have the value of 16. Use at least one exponent in each expression. Well, let's break 16 up. 16 is 4 times 4. If we wanted to write an expression with an exponent, we could write 4 squared. We could split this up further. 4 is 2 times 2. That could be rewritten as 2 squared times 4. This could be broken into 2 and 2. So we could write that as 2 squared times 2 squared. Or we could rewrite it as 2 to the 4th power. We could also think about, well, what's 5 squared? 5 squared is 25. If I subtract from that, what number would I subtract to get 16? I could subtract 9. So there are 1, 2, 3, 4, 5 different expressions we could write that each have an exponent in them. You only need 4. There are more that we could continue to come up with. 3 squared is 9. 9 plus 7 makes 16. And we can continue going, but you only need 4 in your book. Please make sure you have this all filled out for lesson 4, and then check back for lesson 5.